Thank you.
Hi, my name is Aurélien Aptel, and I've been working on making Emacs extendable in C and other languages. So I was afraid this talk wouldn't be accepted at first because the dev room is mostly Java stuff, so
Right.
it's kind of far away from Emacs.
You can call them Java and Emacs. That's fine.
I wouldn't agree with this. No offense. So GNU Emacs. You might have heard of it. I'm guessing if you're in this room, you already know a bit about it. So I'll go quick over this. So it's an editor of the Emacs family. Has been written in 1976. So it's technically 32 years old, which is a pretty cool age, I guess. It's still popular, although it's certainly less popular than it was, I guess, 20 years ago or something. So it's extensible. It's one of the first editors to be extensible in a proper language. Again, no offense. These are just jokes, don't take this too seriously. And it's self-documented. It was one of the first as well, which means every time you extend something, you can put a doc string, similar to Python if you're familiar with this. And you can access the documentation from within Emacs. And everything is, you can do everything from Emacs, documented, extended, expanded. So it's, Emacs is also intertwined with the hacker culture. So Lisp was extremely popular in the MIT AI lab. And so you had, they even developed Lisp machines there, where the processor would actually have instructions to deal with const cells and such. So it's fascinating stuff. I've put a couple of links here. You can explore if you want to dig into it. Did you know Stallman had a published ACM article about Emacs? I didn't, so that's interesting. There's Jamie Zawinski who made a timeline about the different families of Emacs that's out there. Recently, Stéphane Monnier, the current maintainer of Emacs, wrote an article about how the language evolved and on how it got all its features and such. So plenty of material to go through. So back to the editor. So Emacs is extensible in Emacs Lisp. It's a nice, sort of nice language. Although many people familiar with Lisp would say it's so very well designed. It kind of grew organically, and compared to other Lisps, it's maybe not the most practical to use. So Emacs has a bytecode compiler within Emacs, written in Emacs Lisp, and it has a VM. So basically, Emacs is an interpreter for Lisp, which also features editing commands and such. So it's still not very fast. Some people have tried to make it faster by, so they made the bytecode compiler. At the moment, there's an experimental JIT branch. JIT. I haven't tried it yet, but it looks promising. I've heard that it could speed up by like twice some use case. I know also Tom Chomey, who might be in this room. I don't know if you're here. Hi. Has worked on a eLisp compiler that would target LLVM. So the compiler itself is written in Emacs Lisp, which is an interesting choice, I guess. He also worked on a Emacs FFI, which I'll talk about later. So if you want to extend Emacs, there's a couple of ways to interact with the rest of your system. So initially you had files. It's a text editor, so files are a common way to exchange data from one program to the other. Eventually it got processes, so you can start and interact with process interactively. So the way it works in Emacs is you associate a process in a buffer, and so every time this process would write stuff, it gets appended to the buffer, and you can set up callbacks to process the output. They're called inferior processes in Emacs jargon. You also got TCP and UDP sockets, so you can technically make a full server and client within Emacs. I know a guy on the mailing list, Nick Ferrier, I think. He made a full web server in Emacs. He has a whole web page about it. It's interesting, again. So we also have dbus, but I don't know much about this, so cannot really go in there. So all of those methods are not always convenient, because at some point you always need to serialize your data structure from Lisp to whatever program you want to communicate with. And you have to do it in both directions. So most common solutions to do this inter-process communication is either you write your whole program in pure Emacs Lisp, which means basically no inter-process communication, just everything in Emacs. Alternatively, you write a separate program and then you call it from Emacs, so you can do the heavy lifting in your external program and then interact with it from Emacs. And there's also another way to do things. Some extensions they have a separate program, but it's a server, and so you can keep state between calls from Emacs by keeping it in the server. The next way to go about it is to have a native API to interact with the system at the most lowest level, so a C API. So this is not new. Some people have tried to do this for a while. Steve Kemp in 2000 allowed to have C defense. So defense is the way in Emacs core, when you implement a new function in C, there's a macro called defun, and it defines some stuff for you, and it ends up making a new Emacs Lisp function. So he made a patch that would allow for to load dynamically C defense like this way, but it was never merged for various reasons. One of them I'll go later into. On Reddit, someone told me, actually the actual Rainy Rubin, I didn't know this guy, but he told me shortly after this he made another improvement on it and tried to send it, but never got merged either. But it ended up in X Emacs, which is a fork of Emacs, which some of you might remember from back in the day. In 2006, Dave Love tried again, same idea, but this time he used the libtool for the dynamic loading. This is a GNU tool and set of libraries that makes it easy to dynamically load the equivalent of DLLs or shared objects on Linux. So this API works on every platform, so this was more portable than the other attempts. But again, never merged. So why is this never merged? Well, mostly is because the people maintaining Emacs, which were mostly Richard Stallman at the time, were afraid that people would ship free Emacs along with already built shared libraries, which could potentially not be free. So he was afraid people would make bundles of Emacs with non-free software. So he's pretty anal about this, as you might know. But this problem has been existing for a while in other projects. GCC, for the longest time, also had issues with this. They wanted plugins, dynamic plugins, but they never reached any traction because of this GPL problem. But sometime in 2009, they settled on a compromise, and this compromise is the plugin has to have this symbol which says, the name of the symbol is literally plugin is GPL compatible. So you might ask, how is this enough to enforce laws and stuff like this? I'm not a lawyer, so I cannot really explain the details, but so the GNU coding standard has this quote. So by adding this check to your program, you are not creating a new legal requirement. The GPL itself requires plugins to be free software, license compatibly. The GPL and AGPL already requires those plugins to be released under a compatible license. The symbol definition in the plugin makes it harder for anyone who might distribute proprietary plugins to legally defend themselves. If a case about this got to court, we can point to that symbol as evidence that the plugin developer understood that the license had this requirement. So yeah, it doesn't really enforce anything, but it's enough to sue, I guess. So that was the workaround. So in 2014, I started my own attempt. I learned about this workaround pretty late. I thought it would be a good way to extend Emacs even more. So I made it libtool based again. It was linking against the Emacs binary, which is not something you always want, apparently. I'll go on that later. So it was kind of the same as before. It allowed you to write CD funds outside of Emacs and load them dynamically. I sent it on a mailing list and it was received positively, but people wanted more. There was some iterations on it. So most people don't like when their editor crashes. Surprising thing, right? So people wanted something more robust because the way it was done, basically you had to know the internal data structures of Emacs to interact with it, and so after an update, if you load the same dynamic plugin which was written for the previous version of Emacs, some fields might have been added to structures and such in a way that would just make Emacs crash. And this is really not something you want for a text editor. So the next iteration is it's very similar in the design to the GNI, which Java people might know. It's the Java native interface. It's basically what Java uses to do the same thing. So this was, I had a lot of help on this. People from big companies actually. So Daniel Colacion, at least at the time, was working at Facebook, and Philip Stefani is at Google. So yeah, a lot of Emacs users still out there. So we implemented this, and the design is a lot different, as you see. So after more iterations, it was finally merged in Emacs 25, and it was basically 2 years of on and off work, not full time. With a lot of reviews and bike shedding on the mailing list, as is always the case with Emacs. People complaining about small stuff, and you have to redo things. So how does it work? So first of all, you have to build your Emacs with, when you configure, you have to pass this flag. It's not enabled by default yet, still. You need to pass -- with module when you run configure. So how does it work? So in this version, you don't link against the Emacs binary. There's a header file you just need to include, and it defines a set of structures and function pointers by which you interact with the Emacs Lisp VM in a proper API. So it doesn't break after Emacs releases. So all the C function you want to expose have to have this prototype. So you have the Emacs environment structure, which I'll go in detail afterwards. The number of arguments, an array of Emacs Lisp values, and some user-provided pointer you can choose. And so the environment provides you with function pointers to interact with the VM. So this one would convert a C int into an Emacs Lisp value of ints. So the function returns an Emacs value, which is an opaque type. I'll go on that later. So this is basically what a Emacs Lisp C function looks like. So in order to make this function callable from Lisp, you use the environment pointer. There's a function pointer in there called make function. You pass it the number of arguments, the minimum number of arguments, the maximum. This is a pointer to the function you defined earlier, the C stuff. Docstring here, and this is the void star, which was the last parameter of the function. Here, okay. The void here. So Lisp is a Lisp2, which means every symbol has two cells. So it's like having two namespaces for variables and functions. So when you do a defun in Lisp, where you say the function foo is defined to this code, what it actually does in the background is setting the function cell of the symbol foo to this lambda. So that's basically what you have to do using the API. So func call is the function pointer to make a function call in the Lisp VM. You have to pass a symbol to the fset call. This is done via the intern function, which converts a string to a symbol. So you pass, you call fset. There's two arguments. The first one is the name of the function you want to bind to. And the second one is the actual lambda you want to bind into. So this is exactly, fset, foo, lambda here. Okay. So if you put it all together, this is basically what your plugin would look like. You have the plugin, the mandatory symbol to say your plugin is GPL compatible. You call your make function. You pass all the arguments, and you bind it to the name you want. So in this case, this function will be callable through the name mymod-test in Lisp, and that's it. So you would compile. Oh, wait, I forgot to mention something. Emacs module init is the function that Emacs will call when it loads your plugin. So everything that needs to be initialized is done through here. It's the entry point of your module, basically. So to compile, it's pretty standard if you're familiar with the shared libraries on Linux. So this actually works as on Windows as well. You just need to call the equivalent, but it should work as well. So first step is you turn your C into a object code. You want to pass this position independent flag so that it works no matter where it's loaded in the Emacs binary. Then you turn it into a shared object. This is done this way. It's just magic incantation. So within the API, how does memory management works? So every time a C Lisp function is called, all the stuff you allocate in it is automatically freed when the function returns. So you don't really have to worry about memory management within the function. You can mark values as global. They're reference counted. So if you need to use the same values in two different function calls, you can do so by making them global. So in this example, I turned the symbol t, which is true in Emacs Lisp. I store it in this global variable here. And in this other function, I can just reuse it without having to intern it again. So it just saves a couple of calls this way. So yeah, unless you need the global references, you don't need to worry about memory management. You can only use the Emacs values you allocated within Emacs C Lisp functions. Like you cannot have a thread that would access those values outside of when you call them from Emacs. That's one of the limitations. Yeah, so usually you would do this to cache values because you don't want to recompute them every time you run a function. So error handling. Emacs Lisp has a signal, but C doesn't. So somehow you have to convert. So signals work kind of like exceptions in other languages, and so somehow C doesn't have them, and you have to convert. Yeah, those two different mindsets of dealing with it. So the way we implemented it in Emacs is if a function gets signaled when you call it, in the environment pointer there's a flag that says you can check for it every time you call a function that says whether or not it exited via signal or if it returned normally, or if it used the throw thing. Emacs has signal and throw. So it's similar to error no in C. It's every time there's an error in libc function calls, the libc function would set error no to a certain value, and you have to check it afterwards. So yeah, it's similar. You can clear the flag by calling non-local exit clear. Yeah, so there's two ways to go about it. Either you check every single API call, or you only check after important ones, because the API, every time you do a call, it checks if there's already the flag set, and if it is, it just doesn't do anything and fails automatically. So you don't have to actually check every call if you know what you're doing. But it's very verbose to check all the time, so that's an issue. But that's how it is if you want to go from exceptions to regular error codes. So I also had to add a new Emacs Lisp object type, so you can wrap any kind of pointers. So those functions in the API would allow you to, if you use a library that makes provides a handle of when you open a resource, you can store that handle inside a user pointer this way. So you have a function to make it, to get and set it, and they have there's a finalizer to it, so that when the object is garbage collected, you can set a function that will be called when it does, so you don't have leaks this way, memory leaks. So I have a demo for you. I have a really simple module. Can everybody read fine? Yeah. So in this directory, I have Emacs configured with modules. You have to trust me on this. I won't compile it again. It's kind of long, so. And in this folder, I have my mod.c. So this is the header that has all the API defined. You have the monetary symbol. You have the C function here, which we want to expose to Emacs. It just returns 42. This is the bind thing I showed earlier. So it sets the function cell of the symbol. So you want to set, you have a function, you want to be able to call it by the name foo. You would pass foo here. And here you would pass the lambda, the function that you want to call. So yeah, you enter an fset, you enter in the name of the function, and then you just make the call by doing a fun call. So usually Emacs packages, they have this way to say they're already loaded, and so you call provide at the end of your Lisp package usually. So here I just do the same thing. This is equivalent to calling provide and then the symbol passed as argument. So yeah, this is basically what I showed earlier. You make a lambda that has 0 arguments. You make it call this C function. You pass it this docstring. And the arbitrary pointer, I just pass null because I don't really use it this time. I call bind function to make this function callable by this name. And then I say this module is loaded under the name mymod, basically. And then I return 0. And this function gets called the moment I load it in Emacs. So I just compile the module. You can see the commands being run here. So in order to be able to load the module I just built, I have to add it to the path, which is search through for modules. It's called load path. Now I just require it. So this is the symbol, when I put provide, this is the symbol I used, and so this is what I would require. So it has been successfully loaded. Now I can call my test. And it just returned 42. There's a couple of other slides. Don't leave yet. Okay. So the title of the talk was. You can also extend it using other languages. So as long as your language can. Emacs can load any valid modules. So any shared object which follows the API we saw can be loaded. So if your language can compile to a shared object and manipulate pointers in one way or another, then it's probably usable. So people have been writing like shim layers to be able to write modules in other languages. So I know there's one in Rust, OCaml, Go, Nim, and probably others. So I haven't tried them, but they're there. So feel free to try them out. There's an extensive documentation written by Philippe Stephanie. There's a link there you can check. It covers many cases, corner cases, and questions you might have as well. Chris Wellen has a blog where he also experimented with it. He made a simple C module, and he also has a post about how he managed to use signals, unique signals, so that he made a module with a thread that does certain things, polling and other things. And every time this module wants to signal back to the Emacs process, it sends a unique signal, and it's a nice way to have async requests this way. Otherwise, with the pure API, you can only call your module from Emacs. There's no way to independently make your module call back to Emacs. There's another guy who made plenty of modules. He never talked to me, but he made a lot of stuff on GitHub. And I'll go very quick. So there's already a bunch of existing modules, mostly library bindings. So there's one for SQLite, CSound, OpenSSL, JSON parsers, and other things. Some people have even embedded interpreters of other languages in a module. So you can run Python in Emacs. Or Ruby or Lua, whatever. So the next step would be to write a foreign function interface, which would allow. So at the moment, you have to write C or something else as an intermediary layer to actually access your library. So another way to go about it would be to fully stay in Emacs Lisp and load any library, not specifically a module. And so Tom Chomey has done some work. He made it's actually a module that allows you to write Lisp to just load any library. And he hasn't implemented the GPL check, so it will probably never get merged. So yeah, that's it.
Thank you.